With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question is saying that the electron gain enthalpy in kilojoule per mole of fluorine, chlorine, bromine, and iodine respectively are, right? So here there is some data, right? So but by just seeing this question, you have to you will think that how many numbers, how much data we will learn, right? So but here in the question there is a concept, right? So you don't need to learn this data, right? So you have to just learn the concept. The concept is that, as we know that here it is the electron gain enthalpy, right? So and we know that electron gain enthalpy, right? So here electron gain enthalpy, what do you mean by electron gain enthalpy? Actually electron gain enthalpy is the enthalpy, or you can say the amount of energy released, right? So it's the amount of energy released when an electron is added, right? So to an isolated gaseous atom, right? So that means I can write as electron gain enthalpy is defined as amount of energy released, right, when n, right? So when you can write here as when an electron is added, right? So electron is added in isolated, right? So this term is very important, isolated gaseous atom, right? So gaseous atom, right? So this is gaseous atom, right? So now you can see here this is a more important term. Electron gain enthalpy is defined as amount of energy released when electron is added in isolated gaseous atom, right? So here you can see that, let's say we have an element, right? So M, right? So when we add electron in it, right? So we'll get a M negative here, right? So M negative here, right? So here you can see this electron is adding into this element, right? So electron is adding into this element, that means reduction is taking place here, right? And you know that the non-metal has a tendency to accept the electron, right? So or you can say the electronegative element has the tendency to accept this electron, while in the case of metallic reactor, or the metals don't have this tendency that they will accept the electron, right? So that means all the non-metal, or in the non-metal, halogen has a more tendency to accept the electron. That means in all, halogen has a high electron gain enthalpy, right? While in the case of halogen, right? So that means we have a halogen are like this, right? This is fluorine, chlorine, bromine, and iodine, right? So we have these halogens, right? And we one more, that is acetylene, right? So that is radioactive, right? So you don't need to write to it, right? So here we have this fluorine, chlorine, bromine, and iodine, right? So when we write the equation like this, that means when electron is added, right? So in isolated gaseous atom, right? So if I write here, that means when we add this electron in it, so it becomes F negative, right? So it becomes F negative, right? And when we write here, it becomes, right, you can see here it becomes Cl negative, right? And in case of bromine, right, so it becomes Br negative, right? And in case of iodine, so it becomes I negative, right? So here you can see this electron is adding into it, and that means by adding the electrons, the amount of energy released, right? So here is energy is releasing, right? So now you see here the electron gain enthalpy order of this halogen is like this, right? So you can see here the electron gain enthalpy of order is like this, that is the chlorine, then fluorine, then bromine, and then iodine. Now here question arises, why chlorine has a high electron gain enthalpy than fluorine, right? So because there is a general trend is like this, right? So if we go from top to bottom, that means electron gain enthalpy decreases, because we know that as we go from top to bottom, that means in the p block, then the metallic reactor increases, and we know that metal has a low electron gain enthalpy, right? So because they don't just want to accept the electron, right? So they have their tendencies to lose the electron, right? So that means in the case of non-metal, or in the case of halogen, upper elements, right, has a high electron gain enthalpy, right? So here you can see here, if we can write the halogen like this, fluorine, chlorine, bromine, and iodine, right? So here if we go from top to bottom, then the trend will be like this: fluorine, chlorine, bromine, and iodine, right? And we know that fluorine is also most electronegative element, although yet chlorine has a high electron gain enthalpy. The reason is that chlorine, in case of chlorine and fluorine has a small size, right? So fluorine has a small size, right? So in case of chlorine and fluorine has a small size, right? So due to small size, the incoming electron, right? So the incoming electron, right? So the incoming electron, I can write here the incoming electron field repulsion, right? So field repulsion, right? So due to this field repulsion, right? So due to this system becomes unstable. So that's why the chlorine has a high electron gain enthalpy, because its size is more, so the repulsion is minimized here, right? While in the case of bromine and iodine, there is no such case, right? So because their size factor does not matter here the electron can adjust very well, right? So while in the case of iodine, if we go from bromine to iodine, that means metallic character increases, right? So metallic character increases, that means their tendency to accept the electron decreases, right? So that means that's why they have low electron gain enthalpy, right? And while in the case of, or you can say this is electron activity down the group decreases, right? So that's why this is the basic trend, right? So this is the basic trend. So just by considering this trend, right? So by just considering this trend, right? So this trend is wrong, right? So this trend becomes wrong, right? So here the chlorine first, right? Here the chlorine first, right? So just by considering this trend, you can easily give the answer of this question, right? So here you can say electron gain enthalpy of which halogen has a highest electron gain enthalpy, that is, you can see here, that is chlorine, right? That is chlorine, right? So now you have to just find the highest data in this option, right? So that means you can see here, that is 33, 349, 325 and 296, right? So you can see here 349, right? This is the highest data, right? So this is the highest data, and you can see here the lowest data is like 296, right? So this is the 296, right? So you can see here, just you have to just match the data with this order, right? So that means highest data is like this, right? So you can see here the option will be like this, right? So here the 349, right? 349 in which option, right? So there's a 349, after this 33, and after this 325, and after this 296, right? So this seems to be right order, right? So that means this belongs to chlorine, right? And this belongs to, right? So this belongs to fluorine, right? And this belongs to bromine, and this belongs to iodine, right? That means lowest electron gain enthalpy, right? And this is the correct order, right? So in this way I can say the option C will be the correct answer. While in the case of, let's say in the case of option C, right? So as we know, now we can know that option A, right? So this data is not matching, right? So this data is not matching, right? Here, so I can say that option A, B and D will be the wrong answer, because if I can write in this way, that means I can say this, the chlorine, this belong to this data 349, and fluorine belongs to this data 33, and bromine belongs to this data, and iodine belongs to this data, right? According to this order, right? According to this order, right? So in this way I can say that option C will be the right answer, and option A, B and D will be the wrong answer, because data is not matching with the correct order, right? So in this way I can say this, the option C will be the right answer. So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.